Hello everyone, today I will be presenting the topic Java operator precedence. Java has a wide variety of operators, arithmetic like addition, subtraction, multiplication, division, modulus, relational like less than, greater than, equal to, logical like logical and logical or, and assignment operator like equal to. When we combine this in a single expression, the computer needs to know which operation to perform first. This is where precedence and associativity come into play. Precedence means priority of operators, and associativity means the direction of evaluation. If we understand these rules, we can avoid many logical error in our. Now let's see some examples. First, arithmetic priority. Here, the multiplication is performed before addition, so the result is 20, not 30. Second, pattern is power. Here the pattern is focus addition to happen first. The result is 30. Finally, complex condition. Here the relational operators are evaluated first, then logical and finally logical or. This show how operator precedence ensure predictable result even in complex condition. Here is a simplified precedence table. At the top, pattern these have the highest precedence. Then next come unary operators like increment, decrement, note. Next, multiplication, division, modulus, followed by addition and subtraction. Lower down, we have logical operator, equality operator, logical and logical or, and finally the assignment operator, which has the lowest precedence. When two operators have the same precedence, associativity decide. For example, arithmetic operators are left to right, while assignment is right to left. Now let's see a practical example for the operator precedence in Java. I am writing the simple program called operator precedence demo. This program contains, for example, that show how precedence and associativity affect the result. Here A is equal to 10, B is equal to 5, and C is equal to 2. This example. According to the precedence rule, multiplication happens before addition. So instead of 10 plus 5, it is actually calculated as 10 plus 5 into 2. So 10 plus 10 is equal to 20. That's why the output is 20 and it is will be stored in the variable result. Now we can now in the second example, we can add the pattern this. Pattern this always have the highest precedent. So A plus B is calculated first. That is 10 plus 5 is equal to 50. Then it is calculated by, then it is multiplied by 2. Then it gives 30. Then for the third example, complex condition, let's look at a condition with relational and logical operator. Here A greater than B, which means 10 greater than 5, it's true. Also B greater than C means 5 greater than 2, it's also a true condition. So now check A greater than B, logical, and B greater than C. Then it also a true condition. Then we can check C is equal to 2. It's also a true condition. Now we combine with logical or, then the final result also true. So the if condition is satisfied, then the program print the condition is true. Otherwise it print the condition is false. For the fourth example, precedence in a loop. Finally, in this loop, I goes to 0 to 4. Inside the loop, the expression I into 2 plus 1 is evaluated. Again, multiplication has higher precedence than addition. So the result are for I is equal to 0, it become 0 into 2 plus 1 equal to 1. For I is equal to 1, I into 1 into 2 plus 1 is equal to 3. For I equal to 2, 2 into 2 plus 1 is equal to 5. For I is equal to 3, 3 into 2, it means 6. 6 plus 1 is equal to 7. For I is equal to 4, 4 into 2, it's 8. Plus 1 is equal to 9. Then so here the output will be 1, 3, 5, 7, 9. So in this program, we saw four examples: multiplication before addition, pattern is overriding precedence, logical and relational operators in conditions, operator precedence inside a loop. This shows how understanding precedence make our code result predictable and avoid mistakes. So now let's execute this program. We can see this output in the terminal. So the output proves that operator precedence directly affect the result. The first one shows the multiplication happened before addition. The second, for the second example, pattern is changes the natural precedence. For the third example, the logical operator are evaluated in order giving predictable result. And fourth, in loops, precedence rules continue to apply the same way. To conclude, operator precedence ensure Java evaluate expressions correctly, but this can always be used to override the default order. Associativity decide evaluation order when operators share the same precedence, and using a IDE like IntelliJ help us to experiment and avoid mistakes. Mastering operator precedence leads to writing clear, correct, and predictable code. Thank you for listening.